Hello everyone and welcome to my presentation, laying out and teaching the high jump approach. Before we begin, let's talk a little bit about the biomechanics of the high jump. We know that the high jump is the only jumping event that uses a curved approach. And the presence of this curved approach presents a couple of advantages. The first advantage is that as we run the curve, we're subject to forces that operate at a tangent to the curve. We call these tangential forces. And these tangential forces are the forces that actually propel us toward the bar and over the bar. This creates a very efficient biomechanical arrangement. We'll discuss it in more detail shortly. And the other advantage of the curve is that it assists in lowering the body's center of mass. In order to jump effectively, you want to apply vertical force. And if you're going to apply vertical forces, then you have to have a path over which to apply vertical forces. So by lowering the body's center of mass, we provide that path. As the body rises, we can apply force. The fact that we lean into the curve and actually lean a little as we run the curve actually places the body's center of mass a little bit closer to the ground and actively effectively operates as a lowering system and actually assists or actually accomplishes some of the lowering for us through that body lean. So that being said, these are two tremendous advantages. Now, we use a straight to curved approach in the high jump, and in the next video we're going to kind of take a look at the two and see how they mesh into an approach and look at some of these biomechanics in a more pictorial form. Here you'll see it graphically. Here you can see a young lady running her high jump approach, and here you can see the curved path that she's been on. Well, very much like we turn the rock on the string loose, or very much like we turn the hammer loose, when this young lady leaves the ground, those tangential forces take over and they basically propel her in this direction. So this creates a very efficient biomechanical arrangement. She doesn't have to devote any of her jumping energy directed toward the bar. She can direct her jumping energies vertically and count on these tangential forces to propel her to the bar. Now this brings about our first lesson in high jump coaching. Anytime our jumpers have problems with the forces that bring them toward the bar and toward the pit, those are always curve related problems. So for example, when you have a jumper who gets high in the air in front of the bar and then falls down on the bar, it's never because of the fact that your jumper was too far away. In fact, high jumpers never take off too far from the bar. It's too dangerous. They won't do it. The reason why the peak of flight was in front of the bar was because these tangential forces, the force that brings you toward the pit, they're not sufficient. And if those forces are not sufficient, again, that's a curve-related problem because it's the curve that produces these tangential forces. So it's important to understand that anytime a high jumper gets the peak of flight in front of the bar or falls down on the bar, that is always a curve-related problem. It's always related to the quality of the curve because those tangential forces obviously are not sufficient enough in that situation. Now here, as she approaches it, like we said, she can direct her takeoff purely vertically. You know, if you had never seen high jump before and I showed you this still picture, you would assume that this young lady would jump up in the air and land exactly where she took off from. But we take the tangential forces for granted because we have experience watching high jumpers, and because of that, we expect her to be propelled into the pit. So again, this is that very efficient biomechanical arrangement that we discuss, being able to take off purely vertically, but at the same time count on the tangential forces to produce the movement toward the pit. Now, these curve-related forces create a very efficient biomechanical arrangement, but curve-related forces, the curve does have some problems. It's very difficult to develop momentum on a curve, and it's also very difficult to develop stride consistency on a curve. So when we run high jump approaches, what we do is we use a straightaway to begin with, and we use a curve at the end. The straightaway enables us to develop momentum and some stride consistency, and the curve presents all of the benefits that we just discussed. So this is the rationale behind the J approach, or the fishhook shaped approach in the high jump. Here you can see the basic layout of a typical high jump approach. Okay, here at the top you see the pit, you see the locations of the standards. All high jumpers use two check marks. The first check mark is located on a line in a plane with the crossbar and is located some distance out from the near standard. The other check mark is located on a line that connects the first check mark and that second check mark, and that line should always be laid out so that this is a right angle. This is a 90-degree angle here between this line and this line. So we have two check marks, again, one being on a line out in the plane of the crossbar, and the other being on a line at a right angle to that line, that second check mark. Sometimes coaches call this the bottom check mark, and sometimes coaches call this one the top check mark. So that's the key here. Two check marks and a right angle between these two lines. Now, when we look at establishing these check marks, we're going to kind of give you a system here for setting them up. And we want to be able to establish those check marks. Basically, those check marks are going to be based on norms and a couple of key variables that are involved. And what I basically do is, when I have a jumper who's never jumped before and I'm trying to assemble an approach for them, I use my knowledge of these norms. I use some of the key variables in order to make estimated guesses at where these jumpers should be, and once I use these estimated guesses, then I just fine-tune it with some trial and error. So I'm going to kind of take you through a system for basically constructing approaches for young jumpers who haven't really jumped before. Now, when we look at the high jump, typically approaches range from 8 steps in length to 12 steps in length. 8-step approaches are for your very, very most developmental athletes. And even athletes at the high school level, probably 8 steps is typically a little bit too short. 12-step approaches are for elite level jumpers. The vast majority of high jumpers at the high school and collegiate levels use 10-step approaches. It produces the correct levels of velocity, and it also is something that they can manage and control as far as curve-related forces as well. So what I do is I base my discussion and my teaching on a 10-step approach. Now, occasionally, I'll have an athlete working in my group of high jumpers who might say run from 8 steps. For some particular reason. If that's the case, it sometimes creates some confusion in the group because some athletes are taking off on their 10th step, some athletes are taking off on their 8th step. Some athletes will have the penultimate step as their 9th step, some athletes will have the penultimate step as their 7th step. So there's some confusion there. So what I do is I employ a unique kind of counting system. If you are high jumping from a 10-step approach, and keep in mind, I'm not making the athletes count their steps, but we're naming the steps by the numbers. Then we will name those steps 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the other hand, if I have an athlete who is running an 8-step approach, then they will name their steps 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have an athlete who's super talented and I have them going from 12 steps, they will name their steps 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by using this particular system of naming the steps, everyone takes off on the 10th step. Everyone's penultimate step is the 9th step. Everybody begins their curve on the 6th step. Everybody initiates their curve on the 5th step, and so forth. So the terminology as we move from jumper to jumper to jumper stays the same if you use this naming system. Now, this is a more detailed diagram of what we just discussed a little bit earlier, and you can see some of the distance norms here. Once again, we can see the first check mark over here. We see the second check mark back here, and of course, again, we have this right angle here. Now, let's talk a little bit about normal distances here. The distance from the inside standard to the first check mark is normally anywhere from 9 to 16 feet. 9 to 16 feet. And by the way, that distance is taken from the part of the standard that is directly under the end of the crossbar. So that distance from the end of the crossbar that's the measuring point there. Now, 9 to 16 feet is ability based. The better and faster your jumpers are, the more tangential force they're going to develop. So faster, more talented jumpers don't need a tight radius to produce a lot of tangential force. So better jumpers will be further out. On the other hand, slower or less talented jumpers or more developmental jumpers are going to be in close. So for example, if I had a young lady who was really young and developmental, and I bring her out for high jump, and I think that she might jump, say, 4'2" or 4'4", well, I'm going to have her in around 9 feet or so. On the other hand, if I have a young man who is likely to win the state championship, jumping 7 feet or so, I'll probably have him out closer to maybe 15 feet or somewhere in that neighborhood. If I, for example, have a really good young lady athlete who is like the best player on my high school basketball team, and she's going to come out for high jump, and she's a really good athlete, then I'll probably put her somewhere in between, maybe around 11 or 12 feet or something like that. You know, more developmental boys we might have in the 13 to 14 foot range. And again, this, by the way, is not gender based, it's ability based. You know, a young lady who's jumping 5'6" and a young boy who's jumping 5'6" probably are going to be in a similar location as far as this distance is concerned. So basically what I do here is I make an educated guess. I make this educated guess based upon the potential of that athlete and what type of athletic ability that I think they have. And it doesn't have to be perfect. It only has to be kind of in the ballpark. You can easily adjust it later. Now the other distance, the distance here from the first check mark to the second check mark along this line that's perpendicular to our initial line here, that distance can range anywhere from 30 to 70 feet. Now frankly, 30 to 40 feet approaches in this range are normally 8-step approaches. If we're looking at 10-step approaches, and those are the ones we're going to talk about from this point forward, 10-step approaches typically range anywhere from 40 to 70 feet. 40 to 70 feet. The 30 there represents some 8-step approaches. So 40 to 70 feet for 10-step approaches. Now, what I do here is I also make an estimated guess. And my estimated guess is based on what I call the rule of 10. The distance from the first check mark to the second check mark for a 10-step approach is going to roughly be the jumper's potential jump times 10. So if you have a young lady that you think is going to jump about 4 feet, the distance between those two check marks is going to be about 4 times 10, which is 40 feet. If you have a young lady who is going to jump 5 feet, then 5 times 10, that distance is going to be approximately 50 feet. If you have a young lady or a young man who's going to jump 6 feet, that distance is going to be approximately 60 feet, and so on. So by multiplying their potential jump by 10, you kind of get a ballpark location for this second check mark here. And again, it's not going to be perfect, but it's going to be close enough. And again, it's based on a 10-step approach. If you're not running 10 steps, if you're running 8 or 12, you can kind of tweak that. You can use the rule of 10, and then keep in mind that most of the time a stride length is going to be anywhere from about 6 to 7 feet. So for example, if you're using an 8-step approach, you can basically use the rule of 10 and then subtract 6 times 2, 12 feet, and then you would be kind of close there. So this is kind of how I get these distances. They're kind of ability based upon the type of athlete that I think I'm working with. And keep in mind, there's no way you can fail. Even if you make mistakes in guessing, it might take you a little bit more time to get the approach down pat, but you can still make those adjustments. It's not going to be a long-term error or a long-term problem. Now, when I want to set up the check marks and set up the approach for a young jumper, what I do basically is I put all of those marks down that you saw, and I'll show you the math and triangulation systems for doing that in just a second. And then what I basically do is I put them in the correct positions. I tell them to run 5 steps on a straight, 5 steps on a curve, provided, of course, they're running 10 steps. And then I just count steps and I just make adjustments from that point on. I have some video here that'll kind of help you understand that process. First thing I had them do is run through, telling them again, run 5 steps on the straight and then begin your curve. And what I do is, assuming, of course, that they're going to run 10 steps, I just make a note of where the 10th step lands. So if you watch here, you see that Klassen just kind of continues on through and basically runs a bend. Now we're going to play this video again, and we're going to notice this time where that step hits. If you'll notice, it hits in a place that's pretty good. This is about where you want to take off from, about maybe just a couple of feet inside the standard there. So because of this, we're set up pretty good. So in this case, we made a pretty good guess. Now, if this 10th step had ended up in here, far too far down the pit, then what I would have done, I would have backed this jumper up, not wider, but back more. We're only moving forward or backward. We're not adjusting our width at this particular point. We adjust the width later for other reasons. So once again, because of the fact that he's okay, we know we're good. But if he was over here somewhere, that would be our indication to move back. On the other hand, if the 10th step had ended up somewhere over here, far too far away, then we would have moved the jumper forward on that line. And typically between 1 or 2, maybe 3 repetitions, you can get them pretty darn close and get them in a position where you can start doing a little bit of coaching there. Once you've done that, then you can have them do a pop up into the pit, or maybe put a little low bar up that they can do a scissors on, and then you can kind of make sure that they're comfortable with it. And if you need to make any final adjustments, you can make them at this point. Now, if you remember a second ago, we said, this is a diagram that you've seen earlier in the presentation, and we said that there needed to be a right angle, a 90-degree angle between the line marking the plane of the bar and the line that marks the 2 check marks. Now, in order to assure that this is a right angle, we have to have some type of triangulation system. If you were just to measure out and then measure back, you might be close, but you would never know for sure if this angle here was indeed 90 degrees. So a triangulation system of some type enables us to make sure that we're not making small errors as we lay out the approach. So this triangulation system is really necessary. Now a brief math lesson, please bear with me. Anytime a triangle measuring the lengths of its sides, if the sides lengths are of the ratio 3 to 4 to 5, we can be assured that one of the angles of the triangle is a right angle. So anytime we see a ratio of 3 to 4 to 5 as far as the sides of the triangle, we know we have a right triangle. So we can use that principle to come up with triangles that will help us to lay out our approaches. For example, the first triangle would be a 9, 12, 15. 9, 12, 15 representing the lengths of the sides. So keeping in mind what we just said, the ratio of 3 to 4 to 5. If 3 was used as a multiplier, well, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. So that's where the 9, 12, 15 comes from. If, say, we use 4 as a multiplier, well, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. And of course, this triangle, the 15, 20, 25, that would be using 5 as a multiplier. So these are 3 triangles that we could use in order to lay out the approach and assure that we have a right angle at that critical junction. Now, the numbers over here in the parentheses are the actual points on the tape measure. Now, typically, you're not going to use 3 different tape measures. You're going to have one tape measure, and you'll pull it out to one point, then back to another point, and then back to the starting point to form the triangle. So these are the numbers, as in feet, that would actually be the points on the tape measure that would mark the corners of the triangle. So obviously when we pull out, we get to 9 feet. So 9 plus 12, so the next corner of the triangle would be at 21, and then 21 plus 15 gives us 36. So the points of the triangle on the tape measure would be 9, 21, 36. These are the numbers that become important to your athletes when they mark this out. And these are the numbers that they should write down inside their shoe or wherever the case may be. Here, 12, of course, and then 12 plus 16 gives us 28. 28 plus 20 gives me 48. So in the bigger triangle, the points, the corners would be 12, 28, and 48 on the tape measure. In the biggest triangle, the one with the 15-foot width, 15, 35, and 60 would be those points on the triangle. So again, any of these could be used, and which one is up to you. Obviously, it's more convenient to use a smaller triangle for a tighter approach and a bigger triangle for a wider approach. And that's normally how we choose. So let's look at a specific example, and we're going to use that 12, 16, 20 triangle. So we're going to first of all look here. This is the high jump pit, and we're going to look at how we're actually going to use the tape measure and a roll of tape in order to actually produce and lay out this triangle. So here you can see the pit. Here, what we've done is we placed the tape measure, the end of the tape measure, at the end of the crossbar, under the end of the crossbar, and measured out to 12 feet. And we put a piece of tape right here at the 12-foot mark. And we're very careful to make sure that we're in the same plane as the crossbar as we pull out in this direction. So that would be our first step. In our second step, we would bring the 48. The mark of 48 on the tape back to where the 0 is and put the 48 and the 0 together. If you're wondering why the 48, if you remember correctly, we said that the last point on that triangle would be the numbers in parentheses that you saw earlier. The last one would be 48. Again, so the points on the triangle would be 12, 28, 48, and 48 being the last. So we just bring that 48 back to the 0 point. Next, we start to pull it tight. We said the midpoint there, the midpoint was going to be 28. That was going to be a point on the triangle. So what we do is we anchor here, we keep this anchored here, and when we pull tight, what we have is that right triangle. This side is 16, this side is 20, and of course this side is 12. Here's our 3, 4, 5 ratio. So what we do here is put a temporary mark. At this point, we know for a fact that this line, marked by my cursor, the vertical line you see here, is at a right angle. We know that for a fact. However, typically our approaches are going to be a lot further back than this 28-foot mark here. So what we're going to do is we're going to begin by putting a temporary piece of tape right here at the apex of this triangle. Now, once we've done that, we can pick up the tape measure from the standard and we move the 0 over to that 12-foot mark. And then I pull the tape measure back straight through that mark. And after I pulled it through the mark and just extended on back further, I can measure any distance behind that temporary mark that I want to at this time. Now, the approach that we just set up, the triangle we just set up, was a 12-foot width, and it fits an approach that has the first check mark out a distance of 12 feet from the near standard. Now, that works out nice and neat mathematically. All of the numbers were even numbers. But what happens if, let's say, you have a jumper who's out, say, maybe 11 feet or 13 feet? If you could, if you were good at math, put together the dimensions of an 11-foot wide triangle or a 13-foot wide triangle, but you would be dealing with nasty fractions and it wouldn't be nearly so neat. So what I recommend you doing would be something like this. Go ahead and mark out your 12-foot wide triangle. And then once that's done, if your jumper's approach is 11 feet wide, then just bump both of those check marks inside by 1 foot, and then you're at 11. Or if it would be 13, then you can bump it outside, maybe a foot or so. So I might pull one triangle, and 3 or 4 different high jumpers might actually get their approaches off of that one triangle simply by locating different points on it and by bumping it in a little or bumping it out a little, whichever is appropriate for their unique approach. Now, this is something that I do at home on my home track, on my home high jump apron, to simplify things. What I do is at the beginning of the year, I go out and I pull triangles. I pull the 9-foot triangle, the 12-foot triangle, and the 15-foot triangle. And I put marks down in chalk, typically, at those locations. And then what I do is I pull back on the 9-foot triangle and I put a piece of chalk, a chalk mark at 40. I put a chalk mark at 50, put a chalk mark at 60. And I do the same for the 12-foot width and the same for the 15-foot width. And this gives me a grid of sorts. So this is nice to have out there because if I want to put, let's say, a high jumper at 9 feet wide and 50 feet back, well, we know this is the 9-foot check mark, the bottom check mark, and 50 is here on this vertical line. So the approach is all set for you. Now, it's always not that neat, of course, but let's assume maybe that we have a jumper whose approach is 10 feet wide, but maybe 53 feet back. Well, then all that jumper needs to do is use one shoe length over here to get to 10 foot, and then they can put down a tennis shoe or some temporary marker there to mark their bottom check mark. Then they can come back here and they can do measure back 3 shoe lengths back and then 1 shoe length over, and they would be on that 10-foot line in that regard. Now, it is true when you start to measure distances with your shoe lengths, they're not quite as accurate, but you're not measuring shoe lengths over extended distances. You're only going for very short distances, so the inaccuracies here are insignificant. So because of this, and because I have these marks out, we can find any approach dimension that we want very quickly without having to pull out tape measures and without a lot of mess. So I put this out. And if I have jumpers who come from both sides, it's a little nastier and a little more work, but I put a similar grid on the opposite side so that the jumpers who come from the other side of the pit, from the other side of the apron, have the same convenience as far as setting up their approaches are concerned. So for this reason, we never have to measure or remeasure approaches when we're practicing the high jump approach at home. Now, this is another system that you can use. It's a double tape system. If you measure, let's notice you have to measure out to the first check mark, to the bottom check mark, and here's the top check mark, the second check mark. If you measure the distance from the near standard to that check mark, and also measure the distance from the far standard to that check mark, you could put 2 tape measures here, pull them, and the point at which they cross here could give you this location. So this is a way you can do it also. The only problem is that you must have be able to pull the right triangle at least once to start it off and to figure this out from the very beginning. But after this, if you have 2 tape measures and 2 people to hold down ends of the tape, well, then you can use this system as well. Now, the high jump approach begins with the drive phase. The drive phase is a phase of momentum development where we push strongly in order to develop momentum and make us more efficient later in the run. The drive phase is also where we establish good posture, come to an upright position, and get the pelvis underneath us in a neutral position. The drive phase in the high jump is typically only about 3 steps or so, only roughly 1/3 of the approach. Our next concern in teaching the approach is teaching the transition into the curve. It's important to know that we should initiate the curve. The initiation of the turning of the hips begins on the inside foot. So if you're coming from the right side of the apron, you're beginning the turning on the left foot. And if you're coming from the left side of the apron, then you're beginning the turning on the right foot. And as we push off of that step, which in a 10-step approach is the 4th step, we actually see the hips turning slightly. What that does is that puts that outside foot, the next step, a little bit wider, and as a result of that, we establish our inner lean, the lean that we want to see a little bit later as we run the curve. So the outside foot establishes the curve, but we actually begin the process 1 step earlier as we turn the hips slightly with the inside foot. And then from that point on, the inside foot holds pressure against the curve. the curve itself, outward pressure with the feet and body lean are the two most important things. And the alignment of the shoulders and the foot placement on the curve and the alignment of the feet on the curve are also very important. What we'll do now is we'll take a look at a video where we can actually see all of the things that we've discussed on the last few slides to reinforce your understanding of them. So let's take a look at these technical points on video. First of all, the drive phase. You'll notice that as our high jumper pushes off, you see a strong forward lean, and that forward lean dissipates and disappears pretty quickly. Here you can see vertical pushing and vertical postures. So you must, in the high jump, have achieved a vertical posture and a neutral pelvis, the hips in line with the spine, before you initiate the curve. It's impossible to initiate your curve correctly if you're still forward at that point. So basically, you have to be completely upright by the time you get to the fourth step. That drive phase only consists of the first 3 steps or so of the approach. As you can see here, he's already upright very early in the approach. And if you'll notice here, this is the use of our check marks. Notice that he's pushing directly. He lines up on the top check mark and he's pushing directly at the bottom check mark for the first part of the approach. This makes sure that the direction of the approach is indeed correct in its initial stages. Now, there's a common mistake called drifting, where you might drift a little wider or a little inside of that mark. But that's the purpose of that approach. Check mark is to make sure that we're indeed pushing in a straight line along the correct path. Now here we're going to see some factors revolving around the initiation of the curve. Looking at this jumper from the back, you saw the nice strong push and a good drive phase. And right here, if you'll notice, his right foot is a little wider than the line on which he was traveling earlier. Now this is because, and again, this is a 10-step approach. This is the 5th step. The reason why this right foot is wider is not because he stepped out with it. The reason why this right foot is wider is because as he pushed off of the previous step, the hips turned slightly toward the pit. And as those hips turn slightly toward the pit, that right foot would just naturally float a few inches wider than it would ordinarily. So this again is 6 steps prior to takeoff. The 5th step in a 10-step approach is where we actually see this foot a little bit wider. And it's the 7 steps out, the 4th step of a 10-step approach, where we actually turn the hips. So as we push off of the 4th step, we push up and turn the hips very slightly. The right foot, the outright foot in this case, floats out a little bit wider, and that's how we actually initiate our curve. So if you'll notice here at this point, with that foot a little bit wider, what you can see here is a lean, and this is the lean that we want to see in the curve. So that's an important concept in high jump approach running. You don't establish your lean by moving your shoulders inside of your feet. You establish your lean by moving your feet outside of your shoulders. And notice that the lean is established while we're still predominantly running straight ahead in a forward direction. And from this point on, here you can see the 6th step of the 10-step approach, and you can see that it's definitely angled into some degree, and it lands back on the original line of travel. And from this point in, you're into the curve. Now notice there is no cutting, no abrupt change, so the key word here is smooth. Smooth. No abrupt changes of direction, no abrupt cutting or redirecting at any point. All right, so we want to continue to work nice and smoothly and make that a nice round bend. And the 7th step in a 10-step approach should be more forward than inside, even at that point. Again, a subtle curve, no cutting. Now, if you'll notice here, we're into the curve. And if you look at her shin angle, you'll notice that the knee is further from us than the foot, so the shin is tilted away from this. This means that the feet are pushing out against the surface, and this is the single most important thing in high jump approach running, is this outward pressure with the feet. This outward pressure with the feet dictates the quality of the tangential forces that we're going to develop here. So it's all about the feet pushing out. Now, if you will notice also, you'll see there is an inward body lean. But keep in mind, sometimes athletes will tilt their shoulders and give you the impression of a lean without actually pushing out with their feet. So watch the feet and make sure that the feet are pushing out, because that is most important. If she were running on ice, she would slide right off of the picture into your living room right there at this point, because of the way the feet are pushing out at this point in the approach and throughout the entire curve. So this is the thing that you want to see most and is most important. It's a good idea to watch the approach from somewhere back over here where my cursor is circling, so that you can see that very clearly. Notice also that the arm starts to push out a little bit. Because of the fact that you're pushing out with the feet, the outside arm pushes out a little bit to match that. That's natural and should take care of itself for the most part. Now, this is a schematic diagram of the high jumper as viewed from above. If you're watching your high jumper, say from above, as you run the approach, what you can see, and again, these black dashes represent the alignment of the shoulders. So notice that as we progress through the curve here, we see the shoulders turning. And for every step on the curve, what we see is the shoulder is at a right angle to the direction of travel. So we're never twisting the shoulders, because of the fact that high jumpers present their backs to the bar as they take off. Sometimes they get a little antsy and they get premature, and we see them actually start to twist the shoulders while they're still running. Well, twisting your body while you're running is not a good idea. The shoulders should always be at a right angle to the direction that you're traveling at any point in the curve. If running sideways was a good idea, then long jumpers would do it too. Okay, now here are the footprints that you'll see. Notice how the footprints here line up on the curve. So if you'll notice, the direction that the toe is pointing is the same, always in line with the curve with every step. So for any point on the curve, the foot is lined up with the curve. So again, there's no premature twisting of the body, premature twisting of the shoulders, or premature twisting of the feet. If you'll notice here, the toe is kind of pointing in this direction, and that's where we want it in the high jump. And a common mistake is in high jumping is the toe pointing in this direction, which subjects you to bad forces at the ankle and is an injury risk. Well, the reason why this toe is typically pointed here with these athletes who have this mistake is because this step is turned prematurely, and then every step after that is turned prematurely. So by the time they actually plant, the toe is actually pointed away from the bar, which again is very dangerous. So in order to fix that particular problem at takeoff, you have to go back to the beginning of the curve in order to do that. Now, another key point here is that all of the foot strikes are on the curve. At no point in time does the athlete step off of the curve. So a common mistake in high jumping, there are three. The first common mistake is taking this step, the ninth step, the penultimate step, a ninth step in a 10-step approach, and stepping over here with it, where my cursor is. That is what we call stepping out on the penultimate, and it's a mistake. Another mistake is taking this step, the last step, the takeoff step, and stepping here with it. We call that stepping down the bar. And the third common mistake is when we do both. If we step out of the curve here or down the bar here, we basically destroy the integrity of the curve and all of the benefits of the curve disappear. So that being said, it's a good idea to stand over here sometimes and make sure that all of the steps, watching the curve from behind, making sure that all of the steps stay on the curve. And if you see any stepping laterally to either side, then you know that's a very common mistake. In high jumping, if you step out on this step, then it's very difficult for your hips to pass over the center of mass. And that will almost always result in your jumper jumping into the bar. And even though you tell them to jump up, you'll still see them falling into the bar or diving into the bar prematurely. Anytime that you see jumpers who jump into the bar, almost always you'll notice that they're stepping out on the penultimate step or stepping down the bar. Something is wrong with the alignment of these last few steps. It's a very common mistake and one you should look for. Here you can see it in real time. Notice how, again, all of the footprints line up with the curve. Now, if you'll notice here, as she arrives at takeoff and plants her takeoff foot, we still see the outward pressure with the feet. We still see the inward body lean. So the key point is making sure that we indeed keep all of these good features of the curve present until the very last step. Some athletes will do a good job of showing lean and outward pressure early in the curve, but give it up later. That's a mistake. We want to make sure that those good mechanics are present throughout the curve and that we take them into the takeoff itself. Now, if we're running the curve correctly, our final angle of approach should be at about 30 degrees. We don't want it to be directed down the bar, and we definitely don't want it to be directed back over here. We don't want to turn it into a hurdle event. So we want to see about a 30-degree angle here. And what I do is when my athletes are running through and popping up, I kind of watch to see where momentum takes their bodies. And if I see their bodies traveling toward the midpoint, as you can see here with my cursor, the midpoint of the far side of the pit, then we know that the angle of approach at the end is about correct. If you see them coming over here too flat, normally it's because they're running this path. If you track my cursor, if they get too deep and then hook a hard left, then what you see is they end up here. And that would be an indication that the athlete needs to move back. On the other hand, if you see them exiting the pit back here, that would mean that their final angle of approach is too steep. And if you track my cursor, that means that the athlete is actually kind of running a path that looks like this. And in that case, that's normally an indication that they need to move forward in their approach. So again, watch the exit point over here to give you clues as to that final angle of approach. Now here you can see it in real time. If you can see, there's the final angle of approach, and if you'll notice here, you can see that her foot is directed kind of in this direction, so that again we can kind of see that final angle basically lining up correctly. Now, visual focus in the approach. For the first few steps of the approach, this jumper is looking at this check mark to make sure that they're not drifting and that they're staying on the line. So the visual focus here is directly at that check mark. Then once we get a little bit further in, say around step 4 or so, now the visual focus changes. Now the visual focus is at the near standard because we're going to gauge our takeoff location by that inside standard. So that near standard becomes our visual point so that we can steer there. We can make adjustments to correctly take off from the right location. So as we see here, this is where our visual focus shifts to that inside standard. Then, once we get even deeper into the curve, say around step 7 or so, maybe step 8, this is where our focus changes again. We start to look at the far standard, specifically the intersection of the far standard and the crossbar. The vertical standard gives you something you can gauge your inward lean by, but also you have to locate the crossbar. You see, what high jumpers do is they see the crossbar before they take off, and they kind of take a mental picture of where it is. And as they jump and clear it, they're not actually operating on seeing the crossbar. They're operating on where they remember the crossbar to be in that picture they took before leaving the ground. So locating the crossbar in the final few steps is very important. So this is a list of exercises and drills that I use to kind of reinforce my teaching of the approach. And what we'll do now is we'll kind of take a look at all of these through video and through diagrams so you can have an understanding of what each means and how it fits into our teaching scheme. Now, what I like to do for my high jumpers is I like to establish a curved runway. Basically, what I like to do is put a semicircle down. Long jumpers, triple jumpers, and pole vaulters get a runway, so I'm going to provide a curved runway for my high jumpers. And here's how I do that. What I'll do is I'll put a little X or a piece of tape right here, approximately where the high jumper would be taking off from, and I put the 28-foot mark of the tape measure on top of that X. And then what I do is I bring the 0 back, and I align myself so that the tape is straight and that the 0 is directly in front of the far standard. So again, 28-foot mark is on the takeoff location, and the 0 is approximately in front of the far standard. And if you're off a little bit, it doesn't really matter. So this is the radius we're going to use. Then what I do is I get someone to hold the tape down here at the 0 mark, and I swing the 28-foot mark like a compass, and I'll put a dotted line down using chalk or tape or something like that. When I'm done, this is what I have. I have basically a semicircle, a curved runway. Now, it's important to understand this curved runway does not match anybody's approach run. It has nothing to do with the approach. What it is a curved runway to use for drill purposes, basically. And it's a little tighter than the radius for most of your high jumper approaches, which works well because they're typically running slower in the drills than they are in the actual high jump. So therefore, it being a little bit tighter in radius works well in this teaching system. So I will put a semicircle down like this and keep it on the apron, and if jumpers come from both sides, I'll put a similar mark on the other side. And again, this is for drill work. Now, if you'll notice here, this is Claxton doing a semicircle run. Now, it's kind of hard to see from this camera angle, but he's actually tracing that semicircle. Here you see it playing again. He's actually just tracing that semicircle and running that half moon shaped figure that you saw earlier, and you can kind of start to feel some of the outward pressure and other things that are important in curve running. Here, this is a serpentine run. What you'll see Klassen doing, and by the way, these cones are about 40 feet apart, and what he does basically is just weave back and forth between the two. It's a good idea to put them on the track because you can use the lane lines to gauge the width. So this gives you a lot of experience. And here we'll play it again. This gives you a lot of experience as far as feeling the outward pressure of the feet, and it also gives you some experience at making the transition into the curve. I'll play it one more time, and I'd like you to notice that as Klassen starts to make this bend, like right now as he starts to change directions, you'll see that this foot is wide outside of the framework of the body. And this is where you start to get the sensation of that foot being wider at the initiation of the curve. Here, he's skipping for height. Right? This is one of the drills that I use with all the jumpers in all the different events. And what he's doing here is instead of skipping in a straight line, he's skipping on that curved runway. So he's getting the feel of what the takeoff should feel like when you have a little bit of an inward lean, and he's getting lots of repetitions because of the nature of the drill. Here you can see run, run, jump. Basically repetitive takeoffs. Once again, these are being done on that semicircle runway. So the semicircle runway gives us an opportunity to do runs and skips and repetitive takeoffs so that you can get lots of repetitions really quick, where athletes can kind of feel how to push down and out with the feet all the way through takeoff. Now, if you'll notice here in this video, before we get started, if you look at the picture, you can see some little white dashes here. These are the chalk lines that mark that semicircle. And what we're doing here is when we do short run jumping, jumping from approaches that are less than the full approach, we can use the curve or that semicircle as a runway. You can run back on it, put a mark down, and jump. Here you can see Klassen doing a 4-step jump. Again, using that dotted line, using that semicircle as a runway. And here you can see him doing a 6-step jump. It's a good idea to do some practicing in your high jump work from runs that are shorter than the actual approach run, than the meet run length. And the reason why is because it's slower and it gives you an opportunity to get more repetitions, and you can learn skills better at these slower speeds. Thank you very much. I appreciate your time. I appreciate your attention. Here you can see on this slide, I have at the bottom my personal email. And if you have questions, I don't mind you approaching me personally. And if you have interest in the videos that you saw here, I have them all kind of in DVD form. And you can find these and lots of other materials on my website, sacspeed.com, if you would like. So that would be a resource for you as well. And I have a lot of free things there for you as well, in articles that might help you with your planning and progressions and so forth. So